Cybersecurity, container security. What are the Kubernetes security checks? I'm usually a STIG guy. The STIGs can actually have a security check actually for Kubernetes. So STIG I always tell you to do best practices. So I usually fall back to the CIS checks, which is Center for Internet Security. So they have a bunch of checks for hardening for a bunch of different platforms and systems and OSs. So I usually fall back to that. So we're gonna hit it up with the CIS checks today. So let's get started. So Kubernetes container security. What are containers? Containers are a lightweight, more agile way of handling virtualization. Rather than spinning up an entire virtual machine, a container packaged together everything needed to run a small piece of the software. The container includes all the codes, its dependency, and even the operating system itself. This enables the application to run almost anywhere: desktop computer, traditional IT structure, infrastructure, or the cloud. Container uses a form of operating system virtualization. Put simply, they leverage the features of the OS to isolate processes and control the processes and access to CPU, memory, and disk space. So on the right is the VM virtual machine. On the left is the VM virtual machine. On the right is the container. As you can see from my pointer, there's no guest OS, and you have the container engine. So since you don't have that whole operating system you have to replicate on the VM, you get to have obviously more containers and more performance and less overhead. So that's kind of one of the benefits of running a container, especially Kubernetes. So that's what it talks about here in traditional hyper virtualization. The results that each VM contains a guest host, a virtual copy of the hardware that the OS requires to run, and the application and associated libraries and dependencies. Instead of virtualizing the underlying hardware, container virtualize the operating system, typically Linux, so each individual container contains only the application and its libraries for dependencies. Containers are small, fast, portable, because unlike a virtual machine, containers do not need to include a guest OS on every instance and can instead simply leverage the features and resources of the host OS. Just like a virtual machine, containers allow developers to improve CPU, memory utilization of the physical machine. Containers can even go further higher because they also enable microservice architecture where the application components can be deployed and scaled more granularity. That is an attractive alternative to scale up an entire monolith application because a single component is struggling with the load. So a microservice at a high level is I have an application, I break it out into smaller pieces, and I let those pieces communicate. So say if the web portion was struggling, I could spin up multiple containers of the web portion and let the database container be one container, because obviously it's going to have a little less traffic. So that's kind of the envision of microservices. So container security, once again, Kubernetes. What are Kubernetes masters and what are masters and work nodes? A pod always runs on a node. A node is a worker machine in Kubernetes and may either have a virtual or physical machine depending on the cluster. Each node is managed by the master. A node can have multiple pods, and the Kubernetes master automatically handles all the scheduling the pods across the nodes in the clusters. A pod always runs. A node is a worker machine. Kubernetes may either have the virtual or physical machine depending on the cluster. Each node is managed by the master, and the node has multiple pods, including Kubernetes automatically schedule that, handling that. The master automatically schedules, takes into the account available resources on each node. So a diagram, you have the top, you have the master node, controlling each worker node at the bottom. So this does all the scheduling, resources, provides specific deployment solution. So the master handles all that communication, and the term of that is orchestration. Orchestrating communication, orchestrating database spin-ups. So the master handles all that. So here it shows you the worker nodes, and inside the worker you have pods, and in those pods you can have multiple containers. These are the configuration files at the bottom, Kubernetes, Kuberproxy. So those handles that orchestration between those pods and that worker. Kubernetes handles large volumes of containers and users simultaneously. An application may have thousands of containers and usually interact with each other at the same time. Managing, keeping track of all these interactions require a comprehensive overall system design specifically for that purpose. Manage service discovery and communication between containers and users. How does the user find a container and stay in contact with it? Providing each microserver with its own built-in function for service discovery would be repetitive and highly inefficient at best. In practice, it would be likely to lead to an intolerable slowdown or gridlock at scale. Balance loads efficiently in an ad hoc, unorchestrated environment. Loads at the container level are likely to be basically largely on user requirements at the moment, resulting in a highly imbalanced load at the service level, along with log jams resulting from inefficient allocation, resulting in limited availability of containers and system resources. Load balancing replaces this semi-chaotic with order and efficient resource allocation. Authentication and security. An orchestration system such as Kubernetes makes it easier to handle authentication and security at the infrastructure rather than the application level. To apply consistent policies across all platforms. Multiple platform deployment, orchestration manage otherwise very complex tasks at coordinating container operation, microservice availability, synchronization in multi-platform, multi-cloud, and a multi-environment. So those are some of the benefits that Kubernetes gives you when you run it in a container. So let's get down and go over some of the, I believe, some of the most critical CIS checks to make sure your container is secure. Once again, I'm going to put a lot of the security checks in the description box, so you'll be able to go over there and be able to secure or do an assessment of your container for all the security vulnerabilities. So remember, there's a master node and a worker node. So we're going to go over about 5 in the master node and about 5 in the worker node, of what we call level 1, or things you need to make sure you lock down. So master node configuration files. Ensure that the API server pod specification file permissions are set to 644 or more restrictive. That means on Unix, who can actually get access to your file? Is it the owner, the group, of everyone, right? So the 4 and 4 is talking about the group and everyone, and I believe that's read and execute, no write into that directory. Once again, this is a master node check. Ensure that the API server pod specification file ownership is set to root. You can automate that check. And it ensures that only root can get access, or the operating system can get access to that file. Ensure that the controller manager pod specification, once again, is at 644 or more restrictive. Ensure the controller manager pod specification file is set to root. Ensure the scheduler pod application, once again, is set at 644. So we just want to make sure what groups and what everyone can have access to this file. Once again, you want to make it restrictive for all those configuration files. Ensure the Kubernetes service file permissions are set to 644. Once again, that's a worker node. So now we went from the master checks to the worker node checks. Because remember, those are 2 segments in the Kubernetes container. We got to make sure are locked down and secure. Ensure the Kubernetes service file ownership is set to root. Once again, if the proxy kube file is ensured, permissions is set to 644. If the proxy kube file exists, ensure the ownership is set at root. Ensure the Kubernetes file config file is set at 644. Remember, this is a worker node check. Once again, this was something quick. We wanted to go over the Kubernetes checks. I'm going to put the rest of the checks inside the description. So once you do a software check or you actually running Kubernetes, you can make sure the developers have the container locked down. Once again, cybersecurity for the people. Please subscribe. Thank you very much.